Hello, fellow Sublime Text fanatics. That Nerd here with the devlog for Devember day 6. He said, hoping that that was the correct day without looking at the calendar, and he did, and it seemed like it was, assuming that it's Thursday. It's been an exciting day in Devember land. I noticed that the channel viewership on this channel has gone up a little bit. Hello, new people. I hope you're enjoying watching the devlogs and you're interested in the Sublime Text stuff that I'm doing here and possibly on my other channel as well. But to the matter at hand, Devember. Well, after I finished up the vlog yesterday, I didn't really get a chance to do much of anything for today except ponder the ramifications of using byte buffers, which, because as I mentioned in the stream, I've been a C developer for a long period of time. And if you take all of the languages that I know that sort of hide pointers from you, like Java, Lua, Python, C Sharp, things like that, and just have their own representations for things, and add up all of the time that I've spent developing on them, I'm fairly sure that I've spent more time working in languages like C and C++ and Objective C that allow you to use pointers than I have in all of those languages combined. So I don't know that I fully have my head around how byte arrays are best used, if you will. And I was concerned about that a little bit. And then I thought, what the hell? If it works, and we can worry about that part later. So, rolling into the stream, we didn't have, except for thinking and planning on what to do, there wasn't a lot there. So, what did we actually implement tonight? We finished up, I believe, the core of the network code. And that was done over a series of commits. There's still more to come. I'm recording this and getting it encoding and uploading to YouTube before I push the commits. But of course, this video arrives at 5 o'clock in the morning PST on the following day. So by the time you're watching this, it will have already happened. But what we did was we knew that we want. Oops. Let's take that off. I don't normally do that. The control pad for the headset. Um, we want to be able to send and receive multiple messages, but it's very important that we be able to handle the situation where the network doesn't deliver us whole things. Up to now, talking to a local host, with probably kernel optimizations to not send network traffic all the way out to the router and back again because it knows it's talking to the same host that it's currently on. We were able to transmit a message and then receive that whole message, but that's not always the case, and it's certainly not the case. In like a real world situation where messages of varying lengths and are happening quite a bit, right? So there were a few changes made to allow for that. The first was that the send code keeps track of how many bytes that keeps track of the bytes that it's sent partially so that it can track that. Actually, let's back that up a little bit because there was hmm, there was a little bit of extra action in there as well on the send code. Hmm, maybe I was thinking of the same thing. Yeah. So when we uh, when we loop through to send a message, I just remember what it was. The protocol we were using didn't have those 4 length bytes preceding it. We were just sending raw messages, which is great when you're only sending one to test things, but when you're rocking out and sending a bunch of messages, that's not good. So the first thing we did in one round of commits was make the send code prefix the data it's sending with that 4-byte length of the message, and the receive code receives a block, uses the first 4 bytes to know how big the message is, and then uses the remainder as the message itself. So verifying that that works. Then we moved into partial sends and partial receives. And in that regard, what we do is the following. Now, when we're going to send a message, what we can do is make a bytes array that is the entire payload of the whole message, which includes its message ID so that the other end knows what it is, and prefixed onto that those 4 bytes that tell it how big the whole block is. And we just store that as a byte array. And then when we transmit the message, we tell it to send these bytes, and the send call says how many it actually sent, and we use that to use a slice in the byte array to toss away the part that we sent and leave only the part that's remaining. And if it's the whole thing has sent, then we're done. Otherwise, the next time through the send loop, it continues sending from that buffer on until it has transmitted the entire block. And once that's done, it can throw that block away because it's now finished, right? And with that in place, we are guarded against the idea of a send of a message being split in half somewhere along the way. Now, on the receiving end, we need to be a little more clever about it. We're still going to try to read a big blob of data, but we're going to grab it and persist it so that we can draw data out of it. And the first thing we need to know is, if we don't know yet how big the block is supposed to be, then we need to grab 4 bytes out of the data that we have buffered and decode it to become those 4 bytes of length, right? If there aren't enough, then we just have to wait for another read so we get out of here. If we have those 4 bytes, we decode them to get the block length, throw them off of the buffer to leave just the rest of the stuff remaining, and then continue to say, okay, we know now how big this block is supposed to be. 56 bytes, 73 bytes, 2K, whatever. Do we have that much data buffered right now? And if the answer to that question is no, then we just leave because clearly we need to read more. If the answer to that question is yes, we can grab that many bytes, pull them out of the buffer and decode them into a message, throw them off of the buffer and have some amount that's left over from the previous previous read. And now that one message is complete, there's still more data. We cycle around back to the top and then say, okay, now do we have enough for a length? And if no, we have to get more reads and so on. So we can actually receive a data for a message over multiple reads. Now, in order to test that, we ginned up the send code to always transmit 1 byte at a time, so that sending one message would send 53 sends of 1 byte each instead of one send of 53 bytes, and verified that the send was sending and updating its buffer as it went on, and the receive was receiving 1 byte at a time and combining them together. And when it got out the other end, it successfully received a message. And then the last thing we did was throw a while or a for loop around both the transmission of messages and the extraction of messages from the block. Now, as I'm saying that, it occurs to me that the receive code is actually broken because I implemented it with a for loop, but it can't be a for loop for reasons I explained in the stream. So I'm going to fix that after everything is all said and done. And we'll probably mention that again tomorrow. The idea there being, if the network thread is asynchronous from the code that's putting messages in, and it decides that connection 1 is writable and calls write, you don't want that connection to just loop forever saying, okay, I sent that message. Is there another? Okay, I sent that message. Is there another? Because there's another thread somewhere that could be dropping messages into the queue. And if that thread can put them in faster than the read thread and the transmission can do stuff, that part can spend a lot of time just sitting transmitting data away and away and away, and it never gets a chance to stop, because as long as the one thread can put stuff into the queue faster or as fast as this end can pull them out and write them, and the network layer can ship them away, it could sit there conceivably for an excessively long period of time, which blocks every other connection from ever getting serviced by the network thread. We don't want that. I implemented the same thing in the receive thread, but it's actually important that once you call receive once, that you try to find every single message in that block, because it drops out when it thinks that there's not enough data and it needs another read. But if there actually was enough message in the buffer for another message, you would need to receive one to get it nudged out of the buffer. So I'm going to go back and fix that. But that is what we have done. We cleaned up the code. We're going to commit it. We have what appears to be a bare bones, at least, ability for some Python code to shovel data across a network connection to a server. Now, we could try to implement that into the Sublime core, and maybe that is what we're going to do tomorrow. I'm going to have to think about this thing. There's going to be one or two things that happen tomorrow. One is we work on the C sharp end of this operation to be the server and basically implement the same sort of thing, but in C sharp using their async framework over on the other end instead, which is going to require me to do a little bit more research on how exactly that's working because it's been like a week now and I've had my head stuck in the Python hole, if you will. But also, maybe we want to take the network code that we have and push it into the plugin. We'll still keep it separate, but just to have a command that can create a persistent connection and validate that we can push messages across, receive them from the Echo server, keep that connection alive, and handle errors. That might be something that's worth doing. I'm gonna have to think about that and see. But that is all we got for tonight. This is already a pretty long devlog with all of that description. So I am going to double salute and single salute with each hand and say thanks for watching the Devember. We are coming along nicely and this is actually working out pretty good because somewhere in today, the someone in the Sublime forum wanted to know about a remote build system. Hey, I'm kind of building one. That was clever. Make sure you guys have a Sublime day, okay?